All right. We're going to talk about continuous delivery. We've always had sessions at Tech Conference and previously about DevALM, and obviously with AX7 and operations, we've put a lot of things out of the box. I think in the past we've talked a lot about features, what you can do, and all the things we've added. Part of what we want to do today is kind of put that in context as well. So I work on the solution architecture team, which is a group within R&D that works very closely with key partners, key customers, beta program, those types of things. So as you know, a lot has changed with operations, and a lot of the things are new to all of us, including Microsoft. So I know a lot of you have been asking for best practices, recommendations, those types of things. And I can tell you in all honesty, we're also learning as we go, just because these are new features. And we've been struggling coming up with good recommendations because we have an idea of what we think would be good, but we have, very few experience with some of these new tools, right? So at this point, we're obviously more than a year after the initial release. We worked with a lot of TAP customers. And so what I'll show you today is quite a few examples of things that I've seen work. Actually, I have a full setup, both on like an ISV example as well as an implementation example of how to go from source all the way to deployment, to give you, hopefully a good idea of and a full-on process, not just a set of features. So I have Robert here as well. He's a principal program manager who owns most of this tool set. So he'll help in case there are questions or roadmap things or suggestions. Robert wanted to make sure he was part of this as well. So really the goal here today for me is to just provide some end-to-end guidance and examples, both from an ISV and an implementation perspective. I think those are very distinct sets of delivery mechanisms, right? So we'll talk about source control. We'll touch on branching. That in the past we've always said we support it. We've not really gone into much detail about what we would propose you would do. So I'll give you some examples of things that quite a few customers are using and how that works. We'll talk about our build system, that's brand new and comes out of the box. I'll show you these flows. I'll show you actually how you can do some customizations to those to make them pretty fast and use them to the fullest. And then we'll talk a little bit also about maintaining and updating live platforms, meaning, you've gone live, but now you're still trying to do some extra work at phase 2, but you're still dealing with hot fixes, trying to come up with some scenarios and how we see those things fit together. So I split this up in sort of 3 different areas. One being architecting, meaning you want to think about how you set things up, how you do source control, what you want to do with branching. We'll talk about the actual work, the actual iteration, doing the coding, checking it in, running the builds, and deploying those. And then we'll talk about that support piece as well. So on the architecture side, I think branching is something that is very personal, very situational. And a lot of people have asked for recommendations. A lot of people have tried different things. I think in the past we've always referred to some online documentation. There's a team at Microsoft called the ALM Rangers. They had like this 100-page documentation of all the different ways you could do branching. I think the best advice that we can give to everybody, and that's actually officially in that documentation as well, is you want to keep it simple, right? The more branches you do, the more difficult it's going to get. You want to look at why you want to do this branching, and you can always expand upon that later. So start very small, and really the decisions really come down to if you want to start splitting up source control, what are you trying to achieve? Why are you trying to do it? Is it because you want to support multiple versions? Do you want to isolate your development from your testing, from your production? Those are sort of the key things to keep in mind deciding on a branching strategy. I've added a link here, and I don't think these PowerPoints are on the website yet, so hopefully it'll get there soon. But this link here, there's actually one concise page on, I think, docs.microsoft.com, called Branch Strategically, and it's actually a very condensed document that's a pretty good read, and it kind of uses the same branching strategy I will talk about. The other thing to think about when you talk about code branching is you have a source, essentially you'll end up with multiple versions of your code base. And the question is, how are you going to be moving this code back and forth, right? I think traditionally, with AX implementations, even before source control, people had a development environment, a test environment, production. Those are sort of three main streams, right? And then hopefully, in most cases, somebody does development, you move it into tests, and then you move it into production. Hopefully, not the other way around, where you go into production and say, oh yeah, I should probably put this on test as well. Don't forget about that. So the same is true with branching, right? Of course, it's all properly managed and tracked. But the same thing is true there. It's like if you start doing coding all over the place, and then you want to make sure you start merging it back into it, it's going to get out of hand really quickly, right? So those are kind of strategies and probably processes that you want to outline before you even get started, which is part of why I put this up front in this sort of strategy thing. In general, I would recommend to just keep moving from dev to test to production and avoid going the other way around at all costs. Again, I think there's some differences there between an ISV and an implementation. On implementation, it's a lot easier to do that kind of stuff because you only have to worry about one customer, essentially, your end users. In an ISV scenario, you may have to support an older version of the product as well that's on a different platform, who knows what. You may have to do the hotfix in one place and merge it back and fix it up. And so they're very different scenarios in that case. As far as the merging the code back and forth, I would recommend people to really think about, coming up with a cadence and a rhythm. So these are the types of things you want to, when you set all this up, when you start your implementation, or as an ISV, when you start uptaking some of these things, to really come up with guidelines. And you can always change them, but set up a rhythm of, every week, every 2 weeks, every month, we'll make sure that things will get back in line with each other. And actually, I wanted to add to that as well. The reverse branching is probably going to cause you issues, right? If you end up doing coding and testing and you want to move it back to dev, the chances of having conflicts are going to get pretty high, right? So keep track of those things and avoid doing the reverse integration as much as possible. If you look at some of the things we do internally at Microsoft, obviously we have to deal with a lot of different things. We're coding on the next release. We're supporting the next release. So it's somewhat similar to the ISV scenarios as well. We have these things as well where we say, we have end of sprint, and that's when we merge things together. That's when we potentially reverse. So all these things are set in stone, and there's very, very clear guidelines on all those things. So this is, and probably not very clear from the back, but I'll show you on my screen later, and we'll zoom in so you can see it. But as far as a sample implementation branching strategy, I think this is one that I've seen used a lot and that works well. It's fairly simple, and it pretty much aligns with the standard model of having a dev, a test, and a production system, right? Essentially, you have your main branch, which was come up in some of the other sessions as well. So with operations, when you deploy a build box, LCS will create your trunk main branch for you. So it's kind of assumed that's where the code will be pulled from to do code upgrades and things like that. So that main branch is something that you'll get with AX out of the box when you set everything up. And what I've seen people do, and I've recommended to people as well, is you branch off a dev branch and you branch off a release branch. That way, at least your main branch is the code that runs. That's the code that people are testing. It's pretty stable. But you isolate the development, right? Developers can hack away. They can do all these changes, put it in. It may break the build. It may not. Things are just very fluent in that dev branch. But when things are ready is when you want to move them over to main, and that's when you start testing out of. We'll talk a little about the testing piece as well. Obviously, once you're down to production, you probably need to keep that separate as well. Once you're live, even though your development may be stable, you move it into main for testing. There may be situations where there's a downtime issue in production that you need to patch immediately, and you want to keep that source separate so that you can always patch it and produce it and get it in the production system without inadvertently taking all this test code that may be working but has never been tested, right? So the purpose of this particular strategy is really to isolate your development, ongoing development, from your released code that's running in production, and then the piece in between where you're testing things that are about to be ready. I've seen some other strategies used where people even branched a dev branch for each developer. They had good reasons to do those things, but again, there it can get out of hand quickly, and I would try to avoid it if you can. So this is a very simple branching strategy, and I'll kind of show you how they use that and what that means, and I'll zoom in on my Visual Studio later so people in the back can see it as well. From an ISV perspective, the branching gets a little bit more tricky, right? Because in the previous example, in an implementation, you're really only dealing with one customer with one code base. And although you may be getting ISV products and all those things, which we'll talk about as well, you still only have one version of the truth. Maybe you're working on your next upgrade, though. But when you do a code upgrade from LCS, it will create a branch for you. You can do your conflict resolution, everything there, and then merge it back into your main and start working on your upgrade as an implementation. As an ISV, you actually have to actively maintain these versions for a long time, right? Essentially, we're talking about the app 7.1 will be supported for 3 years. That effectively means that if the ISV sold their solution on app 7.1, they probably have to support that for 3 years as well, right? It kind of, those support cycles pretty much align. In that case, the ISV has to be able to maintain that code base, maybe not for new features, but at least for hotfixes or critical patches for that length of time. In that kind of case, the easy way to go about that is not have one release branch, but essentially a release branch for each product that's been shipped out. Right? So depending on how an ISV decides to do it, whether it'll have multiple feature releases or just align the versions of their products with the releases of the Microsoft application, like a spring and a fall release, for example, whatever it is they end up doing, they'll probably end up with multiple release branches just to be able to support these different code bases. So in that case, this is sort of the simplest example where you still have that main branch that everything runs off of. You have a dev branch where your ongoing work is going on, but then you have multiple releases for each essential version of the product that you've done. Again, there's a lot of variations. There are a lot of discussions you could have about this and whether or not it works, but I think this is a simple way to go about managing the code. All right, so I'll dive into that so you can kind of see this as well. So there's two ways to look at this. I have a VSTS project here, which is the web client, and I also have Visual Studio here locally, but I'll use this. I have a Zoom tool, so don't worry. So let's look at the... so I have two projects here. Essentially, one is the code for a customer, a supposed customer. The other project is for an ISV. And effectively, and we'll look at that later, the customer actually uses the ISV's product as well. So if I dive in here and go to code, you'll notice that effectively the trunk main, which is what you get, and this is where I need to figure out the zoom. There we go. Do you need more zoom? Is that readable at all in the back? Yeah, it is? Okay, perfect. So you see I have, and that tooltip doesn't go away. That's great. But I have that main branch, I have a dev, and then in this case for the ISV, I have a release of the product, I have a 1.0, I have a 1.5, and that's how I try to manage these things. You can actually look at that hierarchy, so if I go to Visual Studio here, and again, I'll zoom in a second, so I go to my trunk main, there's actually a right-click feature here. It's called View Hierarchy, if you right-click. And that'll show you exactly what this looks like. So effectively, main is really where I branch everything. The idea being main is a stable code base for testing purposes, and then each release goes off, and I want to isolate development. So that's the philosophy behind it. So this is the very simple ISV, and effectively the customer implementation is the same. You just have one release branch. One of the things I do want to show, where's the mouse? There we go. Is the branching of upgrades. So in this case here, this is the customer's project, which has a dev main and release. As soon as you do a code upgrade, you'll notice that you'll actually get an extra folder there called releases. And then it has a folder for the code upgrade it just did. So in this case, this customer base, there's been two upgrades. One was the 7.01, which is the update 1 release that contained hotfixes. And then 7.1, which was an upgrade to the fall release from November. So what happened in this case is the customer's live, they're doing things. At some point, they decide to uptake 7.1. They run the code upgrade in LCS. It creates the release branch. At that point, I create a new development machine that has that new app 7.1 version. I connect it to the 7.1 code upgrade branch, and that's where I fix my code. I make sure the conflicts are resolved. I do the code compile. As soon as I'm ready to go, that's when at that point, as a customer, I can say, okay, now we need a code freeze for production, right? At some point, you have to call that. That's when you can say, I'll merge my release branch back to main and down to dev, and I can start working on whatever final fixes I need to do or extra phase 2 pieces, and then ultimately we'll push that into production, right? But your production release branch at that point is still the old version up to the point that I decide to go live and push everything down from main. If at any point in time I do need to hotfix something critical, I can in fact put that straight into this release branch, run the build, and deploy that. So you still maintain that option, and that's really the purpose of having that release branch separate. Is there a question here?
Yeah. Are you planning to give the possibility to choose the branch from the code upgrade?
Yeah. So the question was, are we going to add a feature to for the code upgrade to point the code upgrade to a different branch? We've actually had this question a few times, including the previous session. And the answer is we've gotten that question a lot, and it's something we are looking at what we can do with that, because I know it's been a requirement. There's some scenarios where that makes sense. Having this sort of, I wouldn't say hard-coded, but this stringent thing today where we depend on the trunk main has some advantages for us as far as other tooling is concerned. But it is something that Robert and his team are looking at, what can be done. And so we'll have that discussion ongoing. All right. So as far as the merging, I'll quickly show that in case you've never seen it. And actually, I guess I didn't talk about that. So the way you can do the code merging between the two, between different branches, and I think I may actually go into that here. Maybe not. So the way that you can think about the branching, traditionally with AX implementations, we've seen people do what's called a feature release, right? So let's say you have 10 requirements at a customer implementation. You have 10 things you want to work on. You have a couple of developers going through these. Traditionally, what we've seen in implementations is as soon as one development feature is done, people decide, okay, that feature, let's just test it, and as soon as it's ready, let's push it to production. Regardless of what's going on with these other 4, let's move whatever is ready. That's what's called a feature release, right? If you want to go down that path, it requires a bit more maintenance, because you want to make sure that every code that gets checked in the source control is very well isolated. You never mix and match different features, or there's no way to separately deploy them. At this point, I think, although most people are still doing that today, these feature releases, I think I would encourage people looking at going more to sort of a sprint kind of model, where you say, let's plan what we're going to, out of these 10 features we need, let's see how many of these we can do in the next 2 weeks. Let's try to get them done. When they're done, let's move all of these to testing. Then we can start working on the next features of the development team. Consultants and users can start testing these features that we've done. Once they're ready, we move everything down to production, right? So more of a version release or a sprint release as opposed to a feature release. Both work well, and like I said, so far I've seen most people stick with the traditional AX model of doing one feature at a time. But start thinking about these things, especially since we're encouraging implementations to go more of an agile sprint-based methodology and doing more a phased approach to going live as well. I think from a development side, we can kind of accommodate some of those things better. And it'll actually make some of this code management easier if you start, doing version releases as you go along. So for the most part, it's about setting these policies, right? I'm giving you all this information. This is what I've seen. It works. But the point is, you want to think about these things and set those policies as you get started. So, and those policies encompass a lot, right? For example, getting lazy before you get started. You want to always have the latest source code. I've seen people do that. Hack my feature, it works. I check it in the source control, let's start on the next one. You want to make sure you get the latest code if you've had other developers. I mean, those are simple things, but they're policies, especially with new developers, that you want to set and make sure you know what people are doing. The other question we get a lot, and there's different opinions on that, which is why I put a bunch of question marks and no exclamation point. Do you want to check in every night? Do you want developers to make sure they don't lose their work? Because that's part of the benefit of source control. It's kind of an automated backup. Do you want them to check it in every night? Do you say, you can keep your pending change, and whenever you're done, check the whole thing in? Do you want to wait until the whole feature is done and tested locally and then move it? Those are things you want to think about, and it really depends on how you end up doing your branching and how you actually relate those branches to environments, right? If you decide to do testing out of main, then it's probably not a big deal if somebody breaks the build by checking in code that ends up breaking something. If you're testing out of that branch, there's probably more stringent requirements to make sure things work. Yes, sir? Multiple checkout. So by default, VSDS is multiple checkout checked out, right? So multiple checkout essentially means I'm working on an extension on sales table, and so are you. We both check it out. We both add things, and then what happens, right? So by default, that is enabled. VSDS allows that. You can turn it off if you wish to do so. So far, I've not seen too much trouble with that. The chances that people really are touching the same object, I mean, it happens, obviously. The chances that they're actually adding the same things is hopefully virtually impossible. So what happens at that point is the first person that checks in the code is perfectly fine, right? It's the second person that checks in. Visual Studio will say, well, hold on a second. You actually did this stuff, but somebody else did, and you sort of get a merge conflict. The merging is actually pretty nice. In previous releases like AX 2012, we worked with the XPO files. It seemed like VSDS sometimes had trouble understanding some of the, where the conflicts were. It seems like with the XMLs, it's doing a lot better. So far, I've not seen too much trouble of two people working on the same object and checking it in. Obviously, the second person is the one who's got to do the effort. You can turn it off if you want. And I think unless you have a really large team, it's probably okay to do that. But if you have tons of developers, you may run into issues there. But the fair point is it plays into this policy about, do you want to check in every night, right? Because if you don't allow multiple checkout, and that person's going to have the sales table extension checked out for 2 weeks, it's going to block everybody else, right? So fair point, and those are policies you set, but I would keep it on. I haven't seen much trouble with that. Yes?
It's worth noting that you can also add logs as needed if you know that...
That is, yes, correct. So the comment here was, even if you allow multiple checkout, there are features where you can actually do an exclusive lock. So that on a case-by-case basis, if you say, let's say you have a totally custom form and you're going to completely redesign it, you obviously don't want someone else to start messing with it because it's going to cause a lot of issues. There is a feature in source control where you can do an exclusive lock so that just for the one object you avoid anyone else from checking it out. So that's actually a good comment.
Can you utilize chain stuff VSDS? Or, shelf sets,
Can you use shelf sets? The answer is yes, actually. Shelf sets work just fine. I mean, we're in Visual Studio now, so all these features work. You work directly against the file system with XML, so not like 2012 where you have essentially you're working in the AOT, but in the back end it does an export and things can get out of sync, and then shelf sets just not supported at all. By virtue of being here in Visual Studio, shelf sets work absolutely as expected. So you can, if you have some pending changes and you want to just get rid of them and keep them for later, you can shelf set and then retrieve them later. It's actually a good way, if you, for example, the feature for code reviews in Visual Studio uses shelf sets as a backend mechanism. One of the things to keep in mind with something like that is that some of our tooling doesn't hook into it yet. So for example, with a code review, if you do a code review, you'll end up seeing the raw XML file as opposed to our designer on top of that. So you'll notice some of those things. And to preempt the following questions, at this point I don't think we have any plans to kind of add these extra toolings, but it's something that ultimately would be nice to have for sure, right? So, but shelf set work as expected, and in fact they work perfectly with a build as well. I can show that.
I was just thinking that would be an alternative to if you, for us, we would probably look at more the milestone aspect when to do the check-ins. But in the interim piece, if you're 2 weeks out and you're not doing those check-ins every night, the shelf set could be the answer for that.
Right. Yeah. So yeah, that's a good point. So the shelf set is essentially, for those who don't know what it means, it's shelf set essentially you're not checking your code in, but you are telling VSTS, here's all the stuff that I have pending. Can I just keep a copy of that pending change as is and store it? And you're absolutely right if you want to avoid doing the check-in every night, but you do want to have some sort of a backup of your work. The shelf set will work perfectly. One thing to keep in mind with that is those shelf sets will stay forever, so you may want to go through those and clean them up after. I've run into that where I hadn't used it for ages and I went back in and there's this huge list of... Okay, there's another question. And then I'll move on because we want to... Yes? Yes, so the question is, to paraphrase a little bit bigger, essentially how do you enable collaboration, right? On an implementation, maybe you have a few ISVs, you have maybe multiple partners or third parties supplying the code. How do you deal with those things? That is kind of a bigger discussion, right? Especially with us moving away from overlayering towards the future and moving people onto extensions. The question becomes, can these customizations that your third parties deliver, can they exist on their own? Are they separated? Do they depend on each other? That's the kind of things you have to look at. If there's interdependencies, you probably just want them to work on the same source control and potentially within the same model or multiple models. It kind of depends on exactly what the setup is. But if these people develop their stuff independently, more like an ISV type of model, you could go the way of saying, well, each one does whatever they want. Maybe they use their own source control, but then whenever they're ready, they either give us the model or give us the binaries. And we'll get actually into that whole binary and model discussion later as well. All right. The other thing to keep in now is some policies. Now that we have really good features about running unit tests, both inside of Visual Studio as well as part of the build, that kind of come up with these things. If you want to do unit testing and starting to use it, set some policies, right? Do you want to make sure that people run the unit test before they check it in, or just depend on the build running them for you? Those are things you want to look at and set some policies. We'll talk about gated check-ins in a little bit as well, which is actually uses shelf sets and is one of my favorite features. From an environment perspective, same thing there. You want to strategize a little bit about how your source control relates to those environments. Like I said, a simple branching strategy of a dev main and test, a dev main and a release. You still have the question of, do I want to deploy my dev branch to a test environment, or do I deploy my main branch to an environment? Or if you're doing feature releases and you have some like SOX compliance requirements as far as, if I test a system, that whole system as a whole needs to move, which essentially eliminates the feature release kind of thing. You run into these questions of, should I run my final test before production actually on the release branch? Or should I test it on main? Or, do I do interim testing on my dev branch already? Those are the types of things you want to kind of set so that everybody knows exactly what code base they're looking at, right? If I'm in the UAT environment, I know this is the main branch and it's supposed to be stable and finished. Maybe you have an add-on sandbox environment where you deploy your dev branch code. People should know that when they go in there, it's work in progress. Kind of keep that in mind and set those policies as well. Don't start moving an output of a dev branch into your UAT, and then the next cycle you put the release branch in your UAT. It's going to get very confusing for users and very confusing for the admin and the developer to kind of know if there are issues, whether this code even come from. So set those policies, make a clear chart. Shouldn't be too big, Visio, whatever. And don't deviate. So that brings us to the actual work, right? The iterations. And here's where we'll do a little bit more demos. So again there, and I started talking about this already, from a testing perspective and a quality perspective, and this is a question that's come up a lot. Obviously, our whole build system is pretty fast. It's out of the box compared to the ALM story in 2012, which was arguably half-baked, right? But still the question people have is, I'm a developer, I'm working on this feature, I want my consultant or my end user to test this feature. do I have to run a build and somebody has to deploy the code? And even though those things are actually don't take that much time anymore, and we're looking at shortening that further, it's still a whole process to go through, and now it's in test. It immediately broke. I have to go back and do the whole cycle, right? So think about these things. You can collaborate on a developer's box, and I think that's a strategy that a lot of people have used and that works. If you have a development VM that's deployed from LCS and on Azure, they have a public URL, right? You don't have to give your consultant or your end user the remote access to your dev box, but you can share the URL with them and you can add them as a user. So at least they can, what I call, smoke test, right? You want to make sure that whatever you've tested is at least to some degree working, further than what you as a developer know about it. The other thing is collaborating on maybe some test data or configuration, right? Maybe it's a totally new feature and there's no configuration data at all, or maybe you have some policies as far as not being able to get a production copy on your dev box. We've seen those types of things a lot. You can collaborate with other people on your dev box just by sharing the URL that is publicly available. So think about those things as well, as far as, we probably want to do some smoke testing and not wait for this whole deployment cycle and then find out the thing doesn't work at all, or I forgot to, keep those things in mind and set that out. The integrated code, again, you want to think about testing out of the dev branch versus the main branch, and it all depends on how many people you have, how much development you're doing, and also how many environments you have, right? If now with Azure, with 2012, I think we've seen an explosion in 2012 of how many environments are being used during an implementation, just because, with VMs and all, it's pretty easy to do. Of course, now on the Azure side, it's still easy to do, but there's a cost associated, so people now are starting to have less environments, definitely, than what they had in 2012. So you want to make sure you know where things are being tested and potentially have some extra, or even a demo box, right? It doesn't have to be a full-on multi-tier. And as far as automated testing, we talked about that already a little bit. I'll show you the gated check-in. I really liked it. Gated check-in, it's something that internally at Microsoft is something we use heavily. There's not a single piece of code that actually gets checked in directly. It always, as soon as you try to check in, it kicks off a build, it runs all the tests, and not until it meets a certain quality bar, only then is the check-in committed. Otherwise, it gets rejected. You can set that up today with AX7 as well, and I'll show you how to do that. It's essentially a VSDS feature, and you just get it for free. It has nothing to do with AX, but it integrates really well. We also have an automated testing session this afternoon, and we'll talk about some of those things there as well. The other thing, again, I'll get into the demos. I know this is a lot of talking, and I need some water pretty soon. The other thing is the build definitions, right? As you deploy a build VM, you get one build definition that's created in VSDS for you. It's a pretty basic thing. It just, standard, it gets the code, it cleans up the old build that you try to run, make sure all that code's gone. You have some options to restore a database, which may be useful for automated testing. Obviously, it runs a compile, it runs the tests, and then everything's successful, creates a deployable package, blah, blah, blah. These build definitions, one gets set up for your main branch. You can clone these things, right? You can duplicate it and point it to another branch. You can still keep that one build VM. One build VM is all you need as long as you're sticking with one version of AX, right? So when you get down to upgrades, you may need a second one as you're working on the newer version and the older version at the same time. ISVs obviously will have those requirements even more to have builds for different versions, but you can perfectly fine build different code bases on the same build VM as long as it's the same version. That works fine. So you can create any number of build definitions you want, although same thing there, I would try to not go crazy on those things because then people will start taking the code from it and deploying it and it gets out of hand. But they are highly customizable, right? We've seen people add their own PowerShell scripts, maybe to do some special integration pieces that they want to test or deploy. There's a lot of things you can do with these build definitions. Use them. You can turn things off, right? I do that a lot on my dev branch, which I don't deploy into any environment. It's just like a nightly build process. There's no reason to generate a deployable package. It just takes time away from the build, and I actually don't want anyone to take that deployable package and put it somewhere. Look at these build definitions and turn things off. Optimize it. Add your own things if you have to, right? The other thing there is you can consider scheduling the builds. I think earlier versions, our build definition had an automatic nightly build. I think newer ones we've turned it off because it caused some issues with some people. But you can schedule these builds to run every night, to run once a week, those types of things. Continuous integration, you can set it so that as soon as somebody checks in, it kicks off a build. Or you can do the gated check-in, which is kind of similar. Somebody checks in, it kicks off a build, but the check-in is not committed until the build succeeds completely. So there's a lot of these options. Go through those. They're not AX specific, right? So if you're looking at these things, you want to use them, you want to learn more, just go online and search for Visual Studio Team Services, right? Don't look for AX, because these features are very much .NET, they're very much VSDS Microsoft, and most of those features, not found any features so far that don't work with our current build system. So the gated check-in, for example, was introduced somewhere after the release of AX7, and I tried it and it just worked, right? So use these things and use documentation. Just don't search for AX, but just search for the build systems. All right, let's look at that. And this is where I have also some different demos for ISVs versus implementations. So again, I'll zoom in, so don't worry. I want to talk about this one first, which is the package structure. And I guess that came up a little bit ago. So if you're collaborating with multiple people, right? If you're a customer and you're just doing some customizations for your end users, it's all fine and dandy. You have a package, hopefully it's extensions, but in the intermediate, as we are going through this overlayering process and trying to eliminate that, you'll probably end up with some overlayering, and you'll probably have hopefully most of your stuff as extensions. Same on the ISV side. So that's already two packages. I have some overlayering, which is one package. I have some extensions, which is another package. But now it gets more complicated. Now I have an ISV, right? I need to get that ISV on my dev box because I actually want to extend some of their stuff further. We see that a lot. There's been a lot of questions around both from the ISV as well as the partner channel as far as how does the ISV deliver their software, right? Deliver the model, which means it's all the code, which means it's the customer's responsibility to build it and deploy it. Or does the ISV supply the binary only, which means it's just a deployable package that you install on the dev box, you install it on the production system, and that's the end of that. Realistically, at this point, it's probably a combination, because ISVs at this point are still running into similar issues where maybe they have most of their stuff as extensions, which they could deploy as a binary because it's a one-directional reference back, but they may have some overlayering still, which of course you need as a customer, as a partner, you need the code for, so you can compile it in with your own stuff in the application suite. The other third piece to that on the ISV side is, if ISVs are using our Microsoft licensing system, they're essentially almost required to have one binary that contains their licensing pieces for integrity purposes, right? So it can be cheated effectively. So in most cases, a lot of the ISVs at this point have at least one just binary. They may have two binaries, and they may have a model, right? And so managing those pieces has become a bit of a structural problem. And we've addressed, in the recent releases, we've addressed a couple of things with that. From a customer perspective at this point, my recommendation would be if an ISV sends you a binary, that is perfectly fine. You install it on your dev box, but you effectively add the ISV's binaries in your source control. We've updated our build system. We've updated both the build definition as well as the build boxes to support that, so that in effect, when you run the build, it now properly recognizes these binary-only packages, and your build will continue. This is an issue that's come up with multiple customers, that the build actually didn't support it. So at this point, you'll probably end up with some binaries, some overlayering, and some of your own overlayering potentially. So these structures get complicated. And to give you an example here, this is a dependency graph. So if you're in Visual Studio, I have multiple packages. There's actually a right-click feature, and you can say View Hierarchy, and it'll show you all the packages in the system. Trust me, when you first run this is pretty elaborate. You see a lot. I've cleaned this up. But in this case, this is a traditional sort of an ISV example. So on the left side, you have the application suite, right? That's the standard application suite package. And you see the multiple models in there. But you actually see it's called, I don't know if you can read this in the back, I'm sorry. It's called ISV legacy overlayer, right? That's a touch point where the ISV at this point was unable to just move to pure extensions and has some overlayering. So this ISV has some overlayering component. On the left side, the right side at the top is the extension model, and you can see the reference is going in one direction, right? The extension package is extending the application suite. It's a one-directional reference. The ISV also has another package called ISV Legacy Common. And this is what you typically will see with ISVs. They'll have some common package that maybe contains all their labels, may have their licensing artifacts, essentially the types of things that it'll probably almost be required to send you as a binary, but you as a customer or partner probably won't even care for debugging or anything of that. It's just an artifact that you need. So in this case, I effectively have the legacy common, which I'm almost forced as an ISV to ship as a binary due to licensing. I have my extension package, which as an ISV, I kind of have the option. I could just send you the code, or I could send you the binary. They probably have some incentive to send you the binary. It's a bit easier and it's a bit cleaner, but I'll leave that up to a decision between the partner and the ISV. And then obviously there's an overlayering model, which as a customer or partner, you need that model. You need that code, because if you want to do your own overlaying, it needs to be all together to be able to be compiled, right? So this is kind of the ISV setup that I have, and I hope it's somewhat representative. I know there's some ISVers there in the front, but I think it is a simple example. I know a lot of solutions are bigger, but I think in general it kind of shows the concept of having a common package which probably will contain labels and maybe some common code that's shared between multiple of their components, their extensions as well as the overlaying. The package on the far right there is actually a test package. So this is just for unit testing purposes. There's nothing that will ship to a customer or a partner, but it's something ISV will use internally just to run unit tests. And in fact, I'll show you, this is a new feature we've added in update 4, where in the build definition, you can actually make sure that package does not get included into the deployable package as the output of the build. That's something that we've run into, that a lot of people were starting to get into testing. They wanted to run tests during the build, but then those tests actually ended up in the deployable package, which you don't want those tests in production. They have no reason to be there. But if you use things like form adapters or some other features that we have, those actually don't exist on a production machine, and deployments were failing and things like that. So I know some people have actually created their release branch without tests, which is not ideal either. So that feature is now there, and I'll show you that little parameter. So this is kind of the ISV setup that I have. And we'll get to the customer side of this as well. Yes?
Just one more question. Could you elaborate on why you would want the extensions in a separate package? Or why not just the one ISV solution?
So the question is, why do I have my extensions in a separate package as opposed to what?
And just the one and only ISV?
Just the one and only package. That's a fair question. I think there's multiple reasons why you would want to have two separate packages there on the right. And I think some of the discussions we've had as far as like labels, as far as updates, right? So as soon as you split something in a separate package, opportunities and open up, but there's some consequences, right? The opportunities being, as an ISV, if I need to make an update to my licensing, potentially I could give the customer just an update to that one package and not have to touch the rest. Right? That could be considered a downside as well from a customer perspective. I guess it kind of depends on how frequently you update the stuff, right? If you update it a lot, it's going to be a lot of maintenance. So I'll get to the question. So that's one piece of it, is splitting the packages has some advantages of doing the maintenance. If you look at it, that's also why we do it internally at Microsoft, is that package split has advantages from a testing perspective, from a build perspective as well, and I'll show you that in a second. By splitting some of these things out and making sure the relationships are pretty clear, I can actually, since my legacy common, also notice how the arrow there goes from app suites to common. So it's actually the application suite is referencing that package, not the other way around. That does mean that package, since it has no dependency on anything else, can actually be built separately. And I'll show you that in a second. I can run a build for that one, and it takes just a few minutes and it's done, right? So the reasons to think about these things and to make decisions is based on servicing your customers as well as your internal development processes. And I think also sharing code between, I know you guys have a lot of different solutions and some of them share code. There may be opportunities to have one common package that has some basic features. And you can essentially, build that separately and maintain it separately. But you can include it in all these other packages if you feel so inclined. So I think those are sort of the decision factors. There were some other questions.
From the perspective of customization, since we're recommending that ISVs kind of break their feature set into smaller chunks to allow for more extension as
Right.
opposed to overlaying. Can you talk a little bit about that and see how this may play into that? Do you end up with way too many DLLs and packages to manage as opposed to one big chunk that's easier to...
Yeah, well, and so that's what I was saying, right, is that there's clear advantages on the splitting side for the ISV, right? They can maintain pieces separately, they can deploy pieces separately. As a customer or partner, that means there's some extra effort because you may have multiple packages you need to worry about based on what solutions you buy. I think from an ISV perspective, even if you split these things up, if you have a common package of some base functionality that multiple of your modules use, you can still package those together and make sure that you have one. And this is where the build definitions come into play. You can arrange the branches however you want, but the build definition is ultimately what produces the output. So as an ISV, even if I share that package and I maintain it separately and I have separate builds that are continuous integration or whatnot, from a release perspective, I can still make sure I have a build definition that builds a particular product, and it may contain the DLLs for all these packages, but it's still one deployable package that I give to my end customer, right? So the advantages from a development side are clear, and I think some of those deployment issues can be resolved again by making sure the deployable package that I give to a customer always contains all my DLLs. They don't really have to care what it is I give them. It's just one package for the whole solution, right? So I guess the question was, we've talked in some earlier sessions about ISVs going a bit more modular, but it could still be one solution you buy, and maybe they have a build definition that combines different modules into one solution and give you that, although they maintain it potentially separately. All right. So what I wanted to show here, so this is, I don't know how readable this is in the back. Do I need to zoom more? Can you read this at all? I mean, or at least get the idea of the structure? Yes? No? You can see the boxes, you can't read it. I think that's fine. So what I want to do here, this is essentially these 4 packages that I have. They all show here in my project. What I'm going to do, and I'll show you the build definition first. So let's go to the ISV, and I'll show you the builds that I have. Not releases, but builds. Show all of them. So I have a couple of different, so you saw the branching before. I have my dev branch, my main branch, and I have a release 1 and a release 2, right? In this case, I actually have more build definitions than I have branches. Mainly because I have my regular dev branch here. That'll just, I think it's set up to run every night, although it says 4 days ago, so I guess it isn't. But anyways, you can run this as a nightly build. I have my main branch, which is where I'll be testing. And obviously I have a release for each of the for each of the product releases that I've done. So I have a 1.0 and a 1.5. And you can actually see the build numbers there at the end are 1.002 and 1.502. And I'll talk about the model versioning in a little bit. The extra one that I have here is called continuous integration, CI, for my legacy common package. So that's the example I gave earlier, where I've split up some of these features that are uptaken by the other packages. But these split features don't really depend on anything else. They're just some base code that just stands all by itself. The advantage of that is that I can do things like this continuous integration, where I can do gated check-ins, continuous integration, and as soon as you check it in, the build kicks off. And because it is so small, it'll run that fast as well. And for this one, you can see I changed the versioning schema a little bit. So this one actually uses the year, month, day, and then revision of the build of that day. The other ones have different versioning schemes. Obviously, the releases themselves are properly numbered, although the last digit there gets automatically incremented. So you can play with these things as well. If you set up branching and you want to go that way, I would recommend you look at these versionings because it actually helps when you're in an environment to see what you're looking at, right? But I want to show the continuous integration. So I'll go to the edit here. And this one has been fairly heavily modified. You can see that I've just turned off deploying reports and generated packages. In general, deploying reports during a build has very little use unless you're doing some elaborate UI testing where you need to be able to run the report. But in general, deploying these reports probably has not much sense in like a nightly build or something like that, and definitely not for my continuous integration. Generating packages and publishing them to VSTS has no meaning for my continuous integration. This thing may be running multiple times a day, every time somebody does a check-in. I don't need a deployable package for these things, right? The purpose of this particular build definition is just to make sure that my stuff still compiles. So turn these things off because these packages, especially with overlayering, an overlayering package of AppSuite can get pretty large. You're talking 400 or 500 megabytes, right? That stuff gets uploaded. Not that it uses your internet connection per se, but it's just going to take time away from your build and it has no meaning. So I've turned a bunch of these things off. There are actually variables to turn them off as well, but I've turned them off here because it's very visible. The other option, this came up earlier, is setting model versions. I recommend people do that, and we don't have that feature out of the box yet, but as you can tell, we're prototyping it, so hopefully that'll come in one of the not too distant updates that will actually support this out of the box as well. So this is my build definition. I haven't made too many changes. I just turned a few things off, and my mouse is gone. All right. So under the variables, and I wanted to show this one. This is the you see that says there skip runtime package is turned off here as well, which was kind of useless because I've done it in the definition. But what I'm looking for here was the exclude the packages. Packaging exclusions right here, sorry. So we're not using that in this continuous integration example because, I'm not going to produce an output. But this is that new feature for excluding the unit tests or excluding other packages. So you just provide a comma-separated list of packages that you want to have built because they're part of your testing plan. You don't want them in your deployable package. We actually have a wiki article. It hasn't been published yet, but we'll document this on the wiki pretty soon because I know this is a requirement that's come up. So what I've done here, though, and this is the interesting piece, is the gated check-in. So all I've had to do is set this thing to enabled, and actually says it accepts your check-in only if the submitted changes merge and build successfully. Right? That's what we want. We want developers to do whatever it is they do, but we only want the source to go in when it actually works. There's different things you can play with here as far as triggers and using workspaces. I think the defaults works just fine. The other thing, though, that I've had to do is under the... this is recently changed, so I'm trying to find my way. This is that new build definition look, and now I don't remember where this went. I'm actually looking for the workspace mapping. Where did that go? If anyone knows, feel free to speak up. I'm sorry? Oh, yeah, there you go. Thank you. So essentially here is the mapping of the source. So by default, you'll probably just point this... Oh, let me zoom in, sorry. By default, you typically just point this to one of your branches and that's it. But if you have multiple packages and they all end up in the same branch, which is probably what most people will end up doing. If I want to build just one package, this is the way to go. Don't start excluding them or doing all these things. You want to have the build be very precise, and you work with the workspace mapping. So in this case, I have a mapping that actually goes in the dev branch, but all the way down to the folder of the legacy common package. And then, of course, I included the test as well, which is the second one. This first one kind of appears automatically since it uses that project file to build. These things are documented. This is kind of a thing we should probably add to our wiki as well. If you just want to build one package, the mapping is where you would set that up. Yes?
As part of that gated check-in, can you run automated tests before you can check the...
Yes, absolutely, and you'll see that in a second. Yeah, so the question was, can you run those tests as part of the gated check-in? Yes, absolutely. So this is effectively the way to still have a lot of code in one branch, but just set up build definitions for one piece only. I've seen people use the cloak feature, and I know I've recommended that to some people in the past, but this is actually a better way, because cloaking means you're hiding things. If somebody adds something, you have to go in and add it as well. So this is essentially just including only those packages. Yes? Where I get what? Oh, sorry. So the VSTS team actually just is changing the UI of this a little bit. So in the old UI, there was a specific tab called mapping or workspace or something. This is the new UI. You have that option. It'll probably be turned on for everybody at some point. And then here it's actually under the tasks with get sources. So thank you for whoever shouted that out. So it depends on your UI, effectively. It's either here or under a separate tab called mapping or workspace or something. So the triggers that you set up to do these gated check-ins and to do these continuous integrations, just run a build on every check-in, is by default just based off of this mapping, right? That was that extra checkbox you saw, which means if somebody checks in code in a different branch, none of this will execute. This will actually only work if somebody makes a change in one of these folders. That's when this stuff kicks off. So let's see what that looks like from a Visual Studio perspective. So let me go here. I know you can't see it, but I'll just quickly go in. I have a small little example. I guess I can zoom in, but I mean the code is really of no consequence. It's just a static method, and it throws something. So in this case, I have a class that takes a string and it throws a prefix and an info as the message. What I have separately in my test package is I actually have a test that checks that these prefixes match to something that I'm expecting. So what I will do here is I'm going to change this prefix to something different that will actually make the test fail. Right? It's a stupid test, but it kind of shows the purpose here. So I'll say standard new prefix. I'm going to save that. It performs a checkout because I just made a change. And then I'll go to my pending changes. I'll say try change prefix, check in. There we go. So it'll just ask me continue to check in. I'm just going to say yes. But this is what I get. It says your branch that you just tried to change is actually set up for a gated check-in. This is standard Visual Studio stuff, right? It has nothing to do with AX. It's a Visual Studio feature. This says you need to build your changes for validation before they can be committed. And then actually I have the option to say, okay, I'll wait until the next build runs, or actually say I can build it right now. There's also an option based on your permissions that you could potentially override it. So if I go to show options, since I'm the admin on the source control, I can actually say, well, forget about, I want to commit this regardless of the build. But obviously, if you do your permissions correctly, this won't happen. So in this case, I'm just going to hit the build changes. And you'll notice it says here, your check-in has been queued for validation. So if we go back here and look at the builds, you'll see it's running. You see this little play icon here. It says in progress. So let's go look at this guy, what it's doing. See, it's running. This will actually, because this is such a small package, there's only a little bit of code. There's no overlayering. There's only a couple of unit tests. This will just take a few minutes, and I'll keep talking as this goes on. Actually, we can look at the previous one to see. So if you look at this one from a little bit ago, this one took 2 minutes, right? So this shouldn't take very long. So this is my previous build. What I'm expecting here to happen, of course, is that my build will fail because of the unit test. So the gated check-in is essentially, preventing the check-in from going in. You can also just set up continuous integration, which means it's not going to check it. It's going to allow the check-in to proceed and actually go in the source control, but it will still kick off a build. That could be useful just for purposes of making sure things don't break without actually preventing the check-in from going in. So you have all these options, explore those. Again, it's standard VSTS documentation, right? So look for those things. So this is running. What else? So while this is running, we'll come back to this in a second. We can look at the customer scenario, right? So I have a customer that is actually using this ISV. So in their case, we open the Application Explorer. So in their case, you see all these packages in the standard. You can set the AOT view to go to model view to see all the models and all the packages in there. So if I scroll down here, you see there's a couple of packages here called dev stuff. This is me as a customer. That's all my things. If I scroll down to the bottom, let me just scroll down here. You actually see the ISV stuff show up here. I don't know if you can see that in the back at all. But the two packages, the common and the extensions, are shown in italic here. And the overlaying packages is just showing up regularly. Anyone know what that means? Binaries. Exactly. So the italic is essentially, that's a binary package. So that piece of the ISV I was sent as part of a deployable package, and I installed it on my development box. Right? They show up in the AOT here, and I can see some of the artifacts that are in there. At this point, we are missing some tooling around debugging, which is something we're looking at what we can do to help there. But the code shows up here and actually can extend whatever artifacts that I can see here. So you can see some forms, I can create extensions, things like that. And obviously, the overlaying is the actual model. So what I got here from the ISV was one deployable package that contained two binaries. So that goes back to your question. Although it's two packages, I only had one thing to install. And I did get a model because I need that source code for overlaying to go in with my source code. What I ended up doing then from a source control perspective as a customer, if we go look at my source control, if you look under, I should probably zoom a little bit more, I don't know. But if you look at under source control, I have my own packages, my dev stuff, but I actually also have the legacy common and legacy extensions. If you go look at those, there's no source code. It's effectively just the binaries. So it doesn't even have descriptor files, for those who know what that means. It's effectively just the bin folder and then any web content, reports, whatever. So I just went into my source control and said add files to source control, pointed it just to that folder of the ISV packages, and it all got pulled in and I check it in. That's the last I have to worry about it. If other developers now sync the code, they will have these binaries as well. As part of the build, this will now work as well. And again, we know there were issues prior. We actually have an official hotfix for update 3 and update 4 as well. It'll be part of update 5 by default. Maybe already update 4, actually. I don't know if was it hotfixed on 4 or was it part of 4? I don't know. Part of 4. Okay, so then we hotfix it on 2, I think, 2 and 3. Effectively, that these binary packages are properly uptaken by the build as well. And the reason why this is important, as a developer, obviously I want a system that has everything that I'll have in production. But if I do want to create extensions on top of this ISV, I obviously need the code. And this code needs to be present during the build so that the build actually can properly check and link everything together. So if you look at the hierarchies on this one, which I should have that file somewhere created already. If I can, here we go. So this is kind of the same dependency graph that we had on the ISV side, but this is the same graph on my customer side. So you see the same things. You see the ISV overlaying model. You see my own overlaying model. So this kind of clearly shows why I need all this source code together, right? So this is the App Suite package. I have the ISV extensions, because that's what they gave me. I have the ISV common package, which is what they gave me as one piece. And then I have my stuff as a customer at the very end, which is both referencing the ISV stuff as well as App Suite, because I'm extending everything. I'm extending the ISV, I'm extending standard App Suite. This is my setup. Obviously, that means if I'm now trying to build my code, the build machine needs to have all of these pieces. That's why I'm checking the binaries in. That's why we've made sure that the build definition can deal with this. The benefit, because a lot of people don't really like, per se, to put DLL files or binary files as part of source control. And there's, I think, discussion in the software world whether or not that's a good idea. But in this case, this actually allows me as a customer to potentially deal with multiple versions of the ISV. Let's say they sent me a hotfix, but I don't want that stuff to go straight into production. Some people have been installing the ISV product on the build box, which is a valid thing to do. The problem with that is if I have to deal with different branches of my code as a customer, and maybe one depends on the newer version and one depends on the older version, I want to be able to build correctly, right? I want to make sure I build against each one. Putting these binaries as part of your source control means the build will be correct and the output of your build as well, right? So this is a scenario that at this point we would recommend people use. Yes?
Just a quick question regarding the DLLs coming from an ISV. We have, again, 24-hour currently. We have ISVs that do supply DLLs that have to go in certain directory locations.
Okay, yes. So
What you're referring to there, that this process will alleviate us from having to do that, or is this difficult?
yes, but not in the way that you were thinking. So the question was, currently this gentleman is on 2012, and some of their ISVs don't just supply models, but they also supply DLL files, maybe a C# library, something like that they depend on, right? Today with 2012, that's an extra deployment step that you just have to take care of unless they gave you some sort of an installer or some sort of process, right? It's a little bit separate, and I guess I've muddied the waters a little bit about talking about DLLs. When I refer to a binary or a DLL here, I'm talking about the compiled version of the ISV's package, right? So each package in AX7 ends up roughly corresponding with a DLL, and that's part of what you end up deploying in that deployable package. But actually your question is still valid. What if the ISV actually has some custom code, like some external library? With AX7, our model has changed in that the deployable package that you get from the ISV that contains their AX stuff could actually already contain those DLLs. I don't have an example of that here, but you saw that bin folder before that I checked in. That was actually the compiled AX code. But the way that we've set up the referencing with C# projects, for example, external DLLs, if they have any of other external non-AX DLLs, they'll essentially just become part of that bin, and you'll get that. So that issue is for the most part eliminated. I've not seen any special cases or problems with that. So I hope this kind of makes sense. Let's go back. This build should definitely be done by now. And actually see the build ran for 2 minutes, which is not bad. And it actually, you can tell that the test did not execute. And it actually, let's go to the summary. It's nicer to zoom. So it actually says the test run failed. And if I go here to the right, you can see the test results. So again, this is all standard VSTS, but it picks up